Imagine a force so powerful that it bends space and time itself. A force that devours everything in its path, including light, and lurks in the hearts of galaxies, shaping the universe as we know it. These cosmic titans are known as black holes. But what if I told you they are not just destroyers, but also creators? That they might hold the key to the universe's evolution, and perhaps even its fate. Today, we embark on an incredible journey to uncover the truth about black holes. This video will take you deep into their origins, their shocking connection to galaxy formation, their influence on time itself, and the ultimate fate of the universe. Stay with me until the end, because what you're about to learn will forever change the way you see reality. Before we dive in, here's what you'll discover in this video. How black holes are born. The violent deaths of massive stars that create these cosmic monsters. How they shape entire galaxies. Without them, our Milky Way, and even life itself, might not exist. Their shocking link to star formation. They don't just destroy, they create. The mysteries of time and space. Could black holes be portals to other universes? The fate of the universe. Could black holes be the last surviving objects at the end of time? Why should you care about black holes? You might be wondering, why do black holes matter to us? The truth is, they are not just some distant cosmic phenomenon. They are crucial to the very structure of the universe. Scientists now believe that without black holes, galaxies wouldn't exist in their current form. Stars might not have been born, and life as we know it may never have emerged. Even now, a supermassive black hole sits at the heart of our own galaxy, silently influencing everything around it. But what do we really know about them? And what secrets are they hiding? Get ready, because we are about to uncover the deepest mysteries of the cosmos. Make sure to watch closely, because every fact, every discovery, and every revelation will challenge what you thought you knew about space and time. Let's begin our journey into the heart of darkness, the realm of black holes. Imagine a place in space where gravity is so strong that nothing, not even light, can escape. A place where the very laws of physics break down. This is a black hole. But what exactly is a black hole? Is it just a giant vacuum in space, sucking in everything around it? Not quite. Black holes are regions in space where gravity is so extreme that it warps space and time itself. This happens because a massive amount of matter is packed into an incredibly small area. Think of a star many times the mass of our sun being squeezed down to the size of a city. The result? A gravitational pull so intense that even light, the fastest thing in the universe, cannot escape its grasp. But wait, if black holes don't emit light, how do we even know they exist? For a long time, black holes were purely theoretical, predicted by Einstein's general theory of relativity. But today, we have direct evidence of their existence, thanks to powerful telescopes that detect their effects on nearby stars and gas clouds. A black hole is more than just empty space. It has different parts, each more mysterious than the last. At the boundary of a black hole lies the event horizon, a point of no return. If anything crosses this invisible boundary, it will never escape, not even light. That's why black holes appear completely black. The event horizon is often called the surface of a black hole, but it's not a solid surface. It's just a mathematical boundary where gravity becomes overwhelming. Beyond the event horizon lies the singularity, the heart of a black hole. This is where all the matter that fell into the black hole is crushed into an infinitely small, infinitely dense point. Here, the laws of physics as we know them break down. Scientists still don't fully understand what happens at the singularity, and it remains one of the biggest mysteries in physics. Could the singularity be a gateway to another universe? Could it be hiding unknown laws of physics? These are questions we have yet to answer. There are three main types of black holes, each with unique properties. Stellar mass black holes. These are formed when massive stars collapse at the end of their life cycle. They typically range from a few to 100 times the mass of our Sun. Supermassive black holes. Found at the center of galaxies, these giants can be millions or even billions of times the Sun's mass. Our own Milky Way has one called Sagittarius A star. Primordial black holes. Hypothetical black holes that might have formed right after the Big Bang. Some scientists believe they could be the mysterious dark matter that makes up most of the universe. Everything in the universe has a beginning, even black holes. But their birth is not peaceful. It is violent, explosive, and cataclysmic. Most black holes are formed when a massive star dies. Stars shine because of nuclear fusion, the process of converting hydrogen into helium, releasing enormous energy. But what happens when a star runs out of fuel? For smaller stars like our Sun, the end is gentle. They shed their outer layers and leave behind a dense white dwarf. But for massive stars, those 10 times or more massive than the Sun, the end is far more dramatic, resulting in either a supernova or a direct collapse into a black hole. But what if a star is even more massive? Some stars are so massive that they skip the supernova phase entirely. Instead, they collapse directly into a black hole without an explosion. Scientists believe this may be how some of the largest black holes in the universe formed. What about black holes that formed before stars even existed? Some scientists believe that right after the Big Bang, extreme conditions may have allowed primordial black holes to form. Unlike normal black holes, these did not come from stars. Instead, they were created from intense energy fluctuations in the early universe. These tiny black holes could be as small as an atom or as massive as a mountain. Some theories suggest they might even explain dark matter, the mysterious substance that makes up most of the universe's mass. When you look up at the night sky, you see stars scattered across the vast darkness. But what if I told you that at the heart of every large galaxy lurks a monster, a supermassive black hole? For decades, scientists thought galaxies formed first and then black holes appeared later. But now, research suggests that black holes may have played a key role in galaxy formation from the very beginning. At the center of our own Milky Way galaxy, there is a supermassive black hole called Sagittarius A star. This black hole, over 4 million times the mass of our Sun, is like the anchor of our galaxy, helping to hold it together. But black holes don't just sit there. They actively shape the universe around them. When a black hole feeds on gas and dust, it generates powerful jets of energy. These jets can trigger star formation by compressing gas clouds, stop new stars from forming by heating up surrounding gas, regulate the growth of galaxies by pushing material away. This means that without black holes, galaxies, and possibly even life might not exist as we know it. Most people think of black holes as destructive forces, but they are also creators in their own way. When a black hole absorbs matter, it doesn't all get swallowed. Some of it gets ejected in powerful jets of radiation. These jets slam into surrounding gas clouds, causing them to collapse and form new stars. In a way, black holes are like cosmic gardeners, ripping apart old matter while planting the seeds for new stars. However, black holes also destroy stars. If a star ventures too close, the intense gravity stretches and rips it apart in a process called spaghettification. Imagine stretching a piece of spaghetti, except this time, it's an entire star being torn into long, thin streams of energy. Supermassive black holes are millions or billions of times heavier than the Sun. But how did they get so big? Scientists believe they formed in the early universe, merging and swallowing up material for billions of years. Today, they control the fate of entire galaxies, merging and swallowing up material for billions of years. Today, they control the fate of entire galaxies. Some accelerate galaxy growth, helping stars form. Others shut down star formation, making galaxies die. Their powerful magnetic fields shape cosmic environments. And here's the craziest part. Some scientists think black holes might actually be creating new universes inside them. What if black holes are more than just cosmic voids? What if, instead of ending matter, they're actually creating something new? This might sound like science fiction, but some physicists believe black holes could actually be creating new universes. Here's how the theory works. When matter falls into a black hole, it's crushed into a singularity. Instead of being trapped forever, it might be ejected somewhere else. That somewhere else could be another universe, a new Big Bang. Some even suggest that our own universe might have been born from a black hole in another universe. This idea is tied to the concept of white holes, the opposite of black holes, where matter bursts out instead of being pulled in. While no white holes have been observed, if they exist, they could explain where black hole matter goes. Could every black hole in our universe be the seed of a new cosmos? Could we be living inside a black hole right now? While we don't yet have answers, this theory could completely change our understanding of reality itself. What happens? When galaxies collide, black holes don't just sit quietly in galaxies. Sometimes galaxies collide, and when they do, their black holes engage in a violent cosmic battle. When two galaxies merge, their supermassive black holes spiral toward each other. They pull in enormous amounts of gas, creating brilliant quasars, the brightest objects in the universe. Eventually, the two black holes merge into one even larger black hole. Our own galaxy, the Milky Way, is on a collision course with the Andromeda Galaxy. In about 4.5 billion years, these two galaxies will merge, forming a new supergalaxy. What will happen to the black holes? Scientists predict that the black hole at the center of the Milky Way, Sagittarius A, will merge with Andromeda's black hole, creating an even bigger, supermassive black hole. This will dramatically change the shape of our galaxy. But don't worry, life on Earth might not even notice, as stars will mostly pass by each other without collisions. The Milky Way as we know it will disappear, but in its place, a new, even grander galaxy will be born. Black hole mergers and gravitational waves. When two black holes merge, the event is so powerful that it literally shakes the fabric of space and time. In 2015, scientists at LIGO, Laser Interferometer Gravitational Wave Observatory, detected these ripples, called gravitational waves, for the first time. This discovery confirmed Einstein's theory of relativity from over 100 years ago. Since then, dozens of black hole mergers have been detected, revealing a hidden universe of cosmic collisions. Every time a black hole merger occurs, the universe itself trembles. Scientists now use gravitational waves to listen to the universe, much like we listen to sound waves on Earth. What's next? Future telescopes may detect even bigger black hole collisions, possibly revealing new physics beyond our current understanding. Black holes are not just cosmic monsters. They are architects of the universe. They shape galaxies and control star formation. They bend time and space, possibly leading to new universes. They merge in violent collisions, sending ripples through reality itself. But as much as we've learned, black holes still hold countless mysteries. Could they be connected to dark matter? Do they lead to other dimensions? Or are they simply cosmic endpoints where time and space break down completely? The deeper we look into black holes, the more we realize they might hold the key to the greatest secrets of the universe, the cutting-edge science behind black holes. Black holes have remained one of the most mysterious objects in the universe. But now, thanks to cutting-edge science, we're finally beginning to understand them. Scientists are using powerful space telescopes and gravitational wave detectors to study black holes like never before. Here's what they're using: the Event Horizon Telescope, EHT. This global network of telescopes created the first ever real image of a black hole in 2019. LIGO and Virgo detectors. These instruments detect gravitational waves from colliding black holes, helping us hear cosmic mergers. James Webb Space Telescope. This advanced telescope is allowing us to see deeper into space than ever before, potentially revealing new black holes. But scientists aren't stopping there. New missions are planned to launch space telescopes dedicated to black hole research. The European Space Agency's LISA, Laser Interferometer Space Antenna, will detect even larger gravitational waves, allowing us to study supermassive black hole collisions in real time. We are entering a new era of black hole science, and what we discover next might change everything. Harness energy from a black hole? Most people see black holes as destructive forces, but what if they could actually power civilizations? Scientists believe that black holes might be one of the most powerful energy sources in the universe. Here's how. The Penrose process. If we drop matter into a black hole's ergosphere, the outermost layer, it could extract energy, potentially enough to power an advanced civilization. Hawking radiation. As black holes slowly lose mass, they release energy. If we could capture this radiation, we could harness a near-infinite power source. Accretion disks. The swirling material around black holes gets heated to millions of degrees, emitting enormous energy. Future technologies could tap into this energy source. Some futurists believe that an advanced alien civilization might already be using black holes as energy generators. If so, we might one day detect their presence by spotting unnatural black hole activity. Could black holes be the key to interstellar travel, or even the survival of humanity in the distant future? What will happen to black holes in the far future? While black holes seem eternal, they actually have a lifespan. Over trillions of years, black holes will slowly lose energy through a process called Hawking radiation. Small black holes will vanish first, evaporating into nothing. Supermassive black holes will take much longer, lasting up to 10 to the power of 100 years. That's a 1 followed by 100 zeros. When the last black hole disappears, the universe will be cold, dark, and empty, a state known as the heat death of the universe. But could something else happen instead? Could black holes be the seeds of a new universe? But could something else happen instead? Could black holes be the seeds of a new universe? Some scientists speculate that when a black hole finally evaporates, it could release an enormous burst of energy, possibly triggering a new Big Bang. This could mean that the death of one universe leads to the birth of another in an endless cosmic cycle. If true, black holes might not just be the end of all things. They could be the beginning of everything. Are black holes hiding something even weirder? As much as we've learned, black holes are still full of mysteries. Some recent discoveries have completely shocked scientists. Black holes that shouldn't exist. Some black holes are spinning faster than physics should allow. Others seem to be growing too quickly, challenging our understanding of gravity. Strange radio signals. Scientists have detected unknown signals coming from black holes. Could these be signs of new physics, or something even more mysterious? Quantum paradoxes. Some theories suggest black holes might erase information, violating the fundamental laws of physics. If true, this could mean our understanding of the universe is incomplete. Are we missing something? Could black holes be the key to unlocking a new branch of physics? The next generation of space telescopes and quantum experiments might finally solve these mysteries, or uncover even deeper questions. Black holes are not just cosmic monsters. They are the beating hearts of the universe. They shape galaxies. They create and destroy stars. They might hold the secrets to time, space, and even new universes. But what's next? What discoveries lie ahead? And could we one day use black holes to unlock the ultimate secrets of the cosmos? If you found this video fascinating, you'll love our next one. The end of the universe. How will everything disappear? Click on the video now to explore the final fate of everything we know.